All right, so today we're talking about graphing in 4 quadrants. So today we're going to graph points on a coordinate plane and we're going to graph algebraic relations. So let's look at Duncan and his friends have agreed to meet at the community swimming pool. The map shows where each person lives in relation to the swimming pool. So explain how Casey would go to the swimming pool. So Casey would be, let's change color here. This is Casey's house here. So that's where Casey's starting from. So how would Casey go to the swimming pool? We're going here. Okay? So we could say she walks 4 blocks north and 1 block west. So 1, 2, 3, 4, and 1 west. And we're there. Okay? Which 2 friends live the same distance from the swimming pool? Why are they in different locations? So, which ones are the same distance? Well, we could say Marcus and Casey Marcus lives north of the swimming pool and Casey lives south of the swimming pool. So again, here's Marcus, 1, 2, 3, 4, and 1 over. So the same distance away from the swimming pool, one's just north and one's just south. But they're both 4 blocks one way and 1 block the other way. Okay? All right. So graphing points. Street maps use a coordinate system. The coordinate system used in lesson 1.4 can be extended to include points below and to the left of the origin. So when we did lesson 4 earlier, we were talking only about this part of the coordinate plane, okay? But now we're going to talk about all 4 parts of the coordinate plane. We still have origin, and origin is still at 0, 0, okay, where the x and the y cross. This is still the x-axis, and this is still the y-axis. It's just that the x-axis extends to the left to include negative numbers, and the y-axis extends downward to include negative numbers, okay? All right. So recall that a point graphed on a coordinate system has an x-coordinate and a y-coordinate. The dot at the ordered pair, -2, -3, is the graph of point T. So this would be my x, and this would be my y. So I would go over to the left, because it's -2, and negative, I would go down 3, and I would be right there, okay? So now we're dealing with positives and negatives. So let's look at a problem. It says write the ordered pair that names each point. So J, if we look at J, J's right here. So we know that it goes, if I go straight up, that's at -4. If I go straight to the right, I'm at -3. So I would write that as -4, -3, that's my x, and that's my y, okay? And that's the point. L, if I go straight up, the x is at 2, and the straight over, the y is at -2. Okay, so you're just looking where it is on the graph, going up or down to the x line, and then going right or left to the y line. Okay, axis. So the x-axis and the y-axis separate the coordinate plane into 4 regions. Okay, they're called quadrants. The quadrants are named 1, 2, 3, and 4. The axis and points on the axis are not located in any of the 4 quadrants. So for example, if I have a point at 3, 4 would be here, it would be in quadrant 1. If I have a point that is -3, -2, which would be here, that would be in quadrant 3, okay? It goes 1, 2, 3, 4, all right? Also, if I would have one, let's say, that's at 2, 0, which would put it right here on the x-axis, that is not in any quadrant, no quadrant, okay? So if it's on the axis, it is not located in any quadrant. All right, so let's take a look. It says graph and label each point on the coordinate plane. Name the quadrant in which each point lies. So if we have m -2, 5, we would go over to -2, and then we would go up to 5. So we put it right here. We would name that m, and that would be in quadrant 2. Okay? So point M is at -2, 5, and at quadrant 2. Now, N is at 4, -4. So I would go over to 4. I go down to -4, and it's right here. This is in quadrant 4. Okay? So it would be point 4, -4 is in quadrant 4. So I've graphed it, and I labeled which quadrant it's in. All right. So here's one. It says, this is where you would pause the video, try this, and then come back, okay? If you have graph paper, use graph paper, or again, you can draw your own coordinate plane. All right, it says graph and label each point on a coordinate plane. Name the quadrant in which each point is located. So 2, 6. So I'd go over to 2, and then go up to 6. And it would go right here. And that would be A. And that is in quadrant 1. Okay? Then we have 2, which for B would be -1. And this one's kind of the way that it read, the line is actually where the negative signs are for the y-axis. But it would be -1, 4. So it's right here. And this is B. And B would be in the second quadrant. Okay? And then C is 0, -5, which would go right here, because we're at 0, and then down to -5. And that would be labeled as C. And that is in no quadrant, so we could just list it as none. Okay? And then D is -4, so we're going over to -4, and then we go down to -3, so we go right here. Remember X, then Y, and that is D, so that is in quadrant 3. Okay, so quadrant 3. All right, so there's graphing, and that's labeling which quadrants we have. Now, you can use the coordinate graph to show relationships between two numbers also. So for example, it says the difference between Zora's and Charlie's bank accounts is $1. If X represents Zora's bank account and Y represents Charlie's bank account, make a function table of possible values for X and Y. Graph the ordered pairs and describe the graph. So we've got a few things we have to do. First thing is we would make a table, and we'd make it look like this, okay? So we put our rule up here, which says that X minus Y equals 1. And how did we get that? It says the difference between Zora and Charlie's bank accounts is $1. So the difference means it's a subtraction problem, and we're going to be subtracting the difference between Zora and Charlie's bank account, and the difference is 1, or equals 1. And it tells us that X represents Zora's account and Y represents Charlie's bank account. So it would be X minus Y equals 1. Now, we can plug in whatever numbers we want as long as they equal 1. So if I plug in here where they plugged in 2 for X, I would have to have 1 for Y, because 2 minus 1 is 1. If I plug in 1 for x, 1 minus 0 is 1. If I plug in 0 for x, then y would have to be negative 1, because a negative and a negative, when we're adding and subtracting, would make a positive. So that would be positive 1. Negative 1 and negative 2 would end up being a 1, and negative 2, negative 3 would end up being a 1. For example, negative 2 minus a negative 3. This would be negative 2, keep, change, change, and so that would give me a 1. Okay? All right, so then we graph those, and we would have, here's my origin there. So right where the the y and the x meet, that's my origin. So 2, 1 would be 2, 1. And then 1, 0 would be here. And then 0, negative 1 would be here. Negative 1, negative 2 would go here. And negative 2, negative 3 would go here. Okay? So now I have graphed it. And then I have to describe the graph. And I could put the points are along a diagonal line that crosses the x-axis at 1. So it's crossing the x-axis right there at 1. So this is what I could write for describing the graph. Okay? So I've answered all parts. I made a table like it asked me to do, I graphed it like it asked me to do, and I described the graph like it asked me to do. Okay? So let's look at an example here that you need to pause the video, try this on your own, and when you're done, come back and see how you did. Okay? All right. So the sum of two temperatures is 3 degrees. So the sum, so that's two temperatures adding together, is 3 degrees. If x represents the first temperature and y represents the second temperature, make a function table of possible values of x and y. Graph the ordered pairs and describe the graph. So here's the table that I'm going to be making. Here's my rule that I set up. X plus y equals 3. And then I can just plug in whatever numbers I want. And what I would do is plug in my x's. So I could go 2, 1, 0, negative 1, negative 2. Okay? So if I use those numbers, then I know y would have to be 1, because 2 plus 1 is 3. Y would have to be 2, because 1 plus 2 is 3. If 0 is x, 3 would have to be y, because 0 plus 3 is 3. If x is negative 1, it would have to be 4, because negative 1 plus 4 is 3. And if it's negative 2, it would be 5, because negative 2 plus 5 is 3. Okay? Then I could write my ordered pairs. That's 2, 1, 1, 2, 0, 3, negative 1, 4, and negative 2, 5. Okay? So my table's done. Part 1's done. So now I have to graph it. Again, this is my x, this is my y, and this is my origin. Okay? So I would start out with 2, 1. So to the right 2, up 1 would put me there. And then I have 1, 2. So that puts me here. Then I have 0, 3 would put me here. I have negative 1, 4 would put me here. And negative 2, 5 would put me here. Okay? So now I'm done graphing. So that's another thing I've got checked off. Now it says to describe it. I could put the points are going down in a diagonal. Or I could just simply put the points slant down, crossing y at 3 and x at 1, 2, 3. So I could describe it like that if I wanted to. Okay, so you're just describing something about it, so if somebody read it, they could kind of have an idea of what the graph is doing. Okay, all right. If you have any questions, let me know. If not, go ahead and do your homework. Thank you and have a good one.